All right, let's talk about the periodic table. So in order for us to read the periodic table, we need to know that groups go up and down. You've got to know groups go up and down. We also need to know that periods go left to right, like a sentence. So let's talk about what each one of those tells us, because the periodic table has a whole bunch of tricks and secrets on it. So the numbers all mean something. The numbers for the periods, remember periods go left to right like a sentence, they tell us the number of energy levels every element in that period has. So every element in period 2 all have 2 energy levels. Every element in period 3 all have 3 energy levels. And I could keep going, but my circles are going to get huge, so I'm going to stop there. But every element in period 7 has 7 energy levels. That's what that number tells you. So if I say what element has 3 energy levels, it has to be an element in period 3. If we look at the group number, that's the number on top, there's an A number here. This A number tells us the number of valence electrons. Remember, we skip all of these. We're not worried about these guys right now. So this A number all the way across is telling me how many valence electrons. So really, the periodic table is giving you all of the information that you need to know. You just have to be able to read it. All right, so if I said, what element has 3 valence electrons and 2 energy levels? I put my finger on 3VE, where 2 energy levels are, and they would meet at boron. I could ask that question in another way. I could say, what element is in group 13 in period 2? And you find where they meet. Let's do one more. What element has 6 valence electrons and 3 energy levels? Find where they meet. One more. What element is in period 1, and has 8 valence electrons? All right, the next thing we need to talk about with the periodic table is reactivity. So we know that group 18 is stable. What does that word stable mean? It means that these elements do not react. They are stable. So they are non-reactive. The reason why is because they have 8 valence electrons. 8 valence electrons is the most you can have. So they don't need any more. Elements react by sharing valence electrons. They don't need any more. They already have 8. That's why they are non-reactive or stable. They are called, this entire group is called the noble gases. So I put a crown here because I think, okay, noble sounds like royalty. They are like royalty, and royalty, they don't really mess with normal people. They just kind of stay to themselves. So these noble gases over here, they stay to themselves. They don't mess with any other element because they have everything that they need. Notice that elements in the same group react similarly. Each group is kind of like a family. That's why they can all have the same name, noble gases. Like everyone in your family has the same last name, same thing. So all of these elements react similarly. Group 17 has 7 valence electrons. So how many more do they need? They need one more to be stable. They are 1 valence electron away from being stable. So they're going crazy. That's why I say to draw a little fire flame over them, because they are highly reactive. These ones are very reactive. If they can get one more valence electron, they are stable. So this entire group of elements is very reactive. They react similarly. There's another group that's very reactive. So if I put a little fire flame over this one, group 1 is also very reactive. Every element in this group is going to be very reactive. And the reason is they have 1 valence electron. If they can get rid of that 1 valence electron, they get to be stable. Remember, being stable is goals. That is what everyone wants to be. It's hashtag goals. Everyone wants to be stable. So if these elements can give one away, they get to be stable. All these other elements in group 2, in group 3, and 4, and 5, and 6 are just reactive. So I'm going to put an R over them. They definitely do react. You can do a reaction with them. They are not stable, but they are not as highly reactive as these two groups. They have more work to do before they can become stable. Look at group 16. They have 6 valence electrons. They have to get 2 more to be stable. Group 15, they have 5 valence electrons. They have to get 3 more to become stable. So let's practice. What element is stable and has 3 energy levels? I go to my group that says stable. I go to 3 energy levels and I find where they meet. They meet at argon. Okay? What element reacts like lithium but has 1 more energy level? Okay, here's lithium. If it reacts like lithium, it has to be in the same group. If it has 1 more energy level, it's 1 period lower, period 3. So that would be Na. First thing you need to know is groups and periods. Then you can start to understand reactivity.